So this will be sort of like note C on factoring and distributed property again. That first video was long, so I'm going to break this into two parts, although it's really kind of one idea. So the first thing I want to review is distributing with a binomial times a binomial. So we are going to be distributing first. And the reason I'm doing that first is because factoring really is the reverse of distributing, going backwards. So suppose you were asked to multiply out something like this, 2x plus 3 times x plus 7. Okay. Notice this is all one term. I think of this as this answer times that answer. So it's just a number times a number. That's all one term. There are two factors, and we would call them binomial factors. A binomial is like bicycle, two terms. That's what a binomial is. So this factor has two terms, this factor has two terms, okay? So you're going to see me write this down. It's a binomial times a binomial is what I'm looking at. A bin times a bin. This is just the distributive property. You would distribute the 3 if the 3 was in front of the x plus 7, because that's multiplication to several terms. You would distribute the 2x to the x plus 7, because that's 2x times all that. And so it's just a double application of the distributive property. You distribute the 2x, and then you distribute the 3. We've named these steps, and we'll call these two the first and the first, because there's the first term in each binomial. We will call these two the last and the last, because they're the last term in each binomial. And this is called a FOIL problem. When you distribute the 2x to the x, that's the first times the first. So we call that the first. So that's 2x squared. Then you distribute the 2x to the 7. These are sitting on the outside, so we call that the outer product. So 2x times 7 is plus 14x. Then you're done distributing the 2x, you distribute the 3. So these are sitting on the inside, so we call that the inner product. So that's plus 3x. And then last times the last, that's distributing the 3 to the 7. We do call that the last product, and that's 21. Then you have your 4 terms. Notice when you distribute, you break up one term into multiple terms. The outer plus inner are often, but not always, like terms. So this winds up being 2x squared plus 17x plus 21. Now make some observations here. This is a typical answer to a FOIL problem, a binomial times a binomial. Notice this term is degree 2. We call that the quadratic term. It's the x squared term. Quad is Latin for square. You think about it, a college quad is a square, okay? We call this the linear term. It is degree 1. So it's x to the first. And the reason x to the first is linear is because the picture you get. So when we get to lines, we'll see that. And the third term of our answer is the constant. It doesn't matter what value you put in for x. If you put in 1/10 for x, if you put in 1,000,000,000 for x, this stays 21. It's constant. Notice, by the way, all the signs are positive because all the signs up here are positive. Notice also the quadratic term. That just came from first times the first. The constant, that just came from last times the last. Finally, that middle term, that linear term, it was complicated. I had the outer added to the inner to get that 17x. All right? So let's do another FOIL problem. Okay, so let's try 3m minus 4 times 2m minus 1. Okay, we're supposed to multiply this out. Those are the instructions. Observe what you have. It's all one term. What you're being asked to multiply is a binomial times a binomial. 2 terms in that factor, 2 terms in that factor. So this is a factor, this is a factor. Whenever you see a binomial times a binomial, that's essentially a FOIL problem. So first times the first, 3m times 2m is 6m squared. Be careful. If you're in a hurry, you can drop the square, but m times m is m squared. Okay, outer. So distributing the 3m, get the outer products, that's minus 3m. Inner. Okay, so you distribute the negative 4 now, so that's minus 8m. And then last times the last is a positive 4. Again, it's often the case the outer and the inner are like terms, not always, but often. So this is 6m squared. Take note here. The outer and the inner are both negative. They're both losses. So they're net losses. They add to each other. You go 3 plus 8 and realize it's a net loss, so that's negative 11m plus 4. So this is really important. You notice, you actually add the 3 and the 8 and then say, oh, it's a net loss. It's negative, okay? Look at the form of your answer. You see that typical form? I'm going to be lazy here and just draw arrows up. The quadratic term, that's typical. There's a quadratic term from a FOIL problem. It comes from first times the first. The middle term, the linear term, degree 1. That came from outer plus inner. And then the constant came from last times the last. The other thing to notice is check the signs out. Why was this positive? Well, when you did last times the last, you had a negative times a negative, which is positive. Why was the middle term negative? Because it wasn't up there. Well, because of these minuses here and here, both the outer and the inner were negative, and so it was a net loss. Middle term was negative. Okay. One more, and in the next video, we're going to reverse this process and factor. So let's try this one. 2x times x minus 3 times x plus 5. Now, this is a little more complicated than the distributing or multiplication problems we had, but take note, this is still all one term. There are 3 factors here. This would be called a monomial because it's one term, but see, that's a binomial and that's a binomial. So those are our 3 factors. It's best, you know, multiplication is associative, so it really doesn't technically make a difference, but it's best to start with the binomial times the binomial, because when we factor, that's the reverse order we'll be going in. So what I'm going to see this as 2x times this answer. So I'm going to start with the binomial times the binomial, which is a FOIL problem. So this is going to be 2x times, okay, first times the first is x squared. Outer is plus 5x. Inner is minus 3x. And last is minus 15. And so this is going to be 2x times x squared plus 2x minus 15. Now let's pause here. Look at the answer to the FOIL problem. Let's just focus inside these parentheses here. Notice the quadratic term, degree 2, the linear term, degree 1, the constant. Notice x squared came solely from first times the first. The minus 15 came from last times the last. The middle term, which is the linear term, came from adding the outer plus inner. Watch the signs. Why is that constant negative? Oh, that's because this was a minus and this was a plus. A negative times a positive is negative. How did we get 2x? Notice the outer and inner were opposite signs. So one was 5, one was negative 3. We didn't go 5 plus 3. We subtracted them, 5 minus 3. When you add sign numbers in their opposite signs, you always subtract their value. Use the sign of the larger. So this wound up being plus 2. But it still came from outer plus inner. All right? Then one last step, distribute the 2x. This is the easy part. 2x times x squared is 2x cubed. 2x times 2x is plus 4x squared. 2x times minus 15 is minus 30x. Notice when you distribute, we broke up this one term with lots of factors into an expression with 3 separate terms. So if I needed terms, I could use this form. If I needed factors, I could use that form. And what I want to be able to do is go back and forth. So the next thing we're going to do is figure out, all right, what if I start here? How do I get back to the factors? What if I start here? How do I get back to the factors? What if I start here? How do I get back to the factors?